Hello, good morning, students. From this chapter, hydrocarbons, we had already studied definition and classification of hydrocarbons. So, under this classification of hydrocarbons, we had studied that hydrocarbons are of aliphatic, means open chain, and second type is are of closed chain. So in the open chain hydrocarbon, we will study alkane, alkene, and alkynes. And in closed chain hydrocarbons, we will study aromatic hydrocarbons, that is benzene and its derivatives. So in the today's lecture, we will study this about alkane. In alkane, we had already studied the definition, then classification of alkanes, isomerism in alkane, conformations in alkane. Now we will study industrial preparation of alkanes. There are different ways to obtain alkanes in the large quantity, that is called as industrial source of alkane. In the industrial source of alkane, we can obtain alkane from crude petroleum and the natural gas. So the source for alkane in large quantity is a crude petroleum and natural gas. We know dead plants buried under earth billions of years ago and got converted into crude oil under high temperature and pressure conditions. We know all this very well. The crude oil is collected in a dome-shaped cavities under the Earth's surface, and which we call these as oil wells. And from these oil wells, this crude oil is obtained, which on fractional distillation in oil refineries, we get different types of hydrocarbons, that the major part of that hydrocarbon contains alkane. So this is one of the important source for alkane. It is an industrial source. The second point under this preparation is given is a methods of preparation of alkanes. In our syllabus, two methods for the preparation of alkanes are given. Method number one is from unsaturated hydrocarbons, and second is from alkyl halide. These are the two different methods for the preparation of alkane. We will study one by one in detail. So first is from unsaturated hydrocarbons. We know unsaturated hydrocarbons are alkenes and alkynes. They contain carbon-carbon double or triple bond in their molecule. This unsaturation indicates compound containing double bond or triple bond. When dihydrogen gas is added across this double bond or triple bond, then unsaturated hydrocarbons are converted into corresponding alkanes. Means the carbon number in unsaturated hydrocarbon and in alkane, means saturated hydrocarbon, remains the same. Only we will add dihydrogen gas across carbon-carbon double bond or carbon-carbon triple bond. So here catalyst used for this hydrogenation is powdered platinum or palladium. Platinum is Pt and palladium is Pd. This catalyzes the hydrogenation of alkene and alkyne at room temperature. Relatively higher temperature and pressure are required for finely divided nickel as a catalyst. So we can use any one catalyst out of these, either platinum or palladium or nickel. So comparatively, nickel requires higher temperature than platinum or palladium. Now we will study examples given under this preparation method. So first is alkene. We know alkene contains carbon-carbon double bond. This is CH2 double bond CH2. We know this is 2 carbon containing alkene. Its name is ethene. When dihydrogen gas means H2 is added across this carbon-carbon double bond, then carbon-carbon double bond becomes a single bond and two hydrogen get added across double bond. Here the platinum or palladium can be used as a catalyst at room temperature, but as we had already studied that when nickel is used as a catalyst, then higher temperature and pressure conditions are required. We can use any one catalyst out of the three given catalysts. Here, the product obtained is CH3 single bond CH3 is ethene. Second example of alkene is 3 carbon containing alkene is a propene. The structural formula of propene is CH3 CH double bond CH2. Only difference in the structure of ethene and propene is that this first hydrogen in ethene is replaced by CH3 group in propene. So that is only difference. Remaining all this part of the reaction is same catalyst, same addition of dihydrogen, and the product obtained is only again difference by this hydrogen in ethane is replaced by CH3 group in propane. Otherwise, all these two reactions given here are the same reactions. Only difference is one hydrogen in ethene is replaced by one CH3 group. So in short, this ethene on hydrogenation gives ethane. Similarly, propene on hydrogenation gives propane. Now we will study example of alkyne. Very simple example of alkyne is ethyne. Ethyne, or it is called as acetylene. So here two dihydrogen molecules are added again in the presence of same catalyst, platinum or palladium at room temperature or nickel at higher temperature and pressure. We get addition of two dihydrogen molecule across carbon-carbon triple bond. First, this triple bond is converted into double bond, and then double bond is converted into single bond. In this way, actually it is a two-step reaction, and ethine is converted into ethane. So this is preparation of alkane from alkyne. In general, these reactions are given with general formulae. Here alkene is having general formula CnH2n. When H2 is added in the presence of nickel, platinum or palladium, we get alkane having general formula CnH2n plus 2, that is alkane. In short, alkane is converted into alkane. This is general reaction for the preparation of alkane from alkene. We can take here carbon number. It is minimum from 2 carbon to any number. Here minimum 2 carbon atoms are required because to write carbon-carbon double bond, minimum 2 carbon atoms are required. Similarly, the general formula of alkyne is CnH2n minus 2. When dihydrogen gas is added in the presence of platinum, palladium or nickel, then we get this alkane having general formula CnH2n plus 2. So this is method number 1 for the preparation of alkane from unsaturated hydrocarbons, that is alkene and alkyne. Second method for the preparation of alkane is from alkyl halide. From alkyl halide we can prepare alkane by reduction of alkyl halide and by using reactive metal. First we will study how alkane is obtained by reduction of alkyl halide. This alkyl halide is represented with general formula Rx. Here R is the alkyl group and X may be chlorine, bromine or iodine as a halide. So alkyl halide on reduction with zinc and dilute hydrochloric acid, it forms alkane. The reduction of alkyl halide is due to nascent hydrogen obtained from the reducing agent zinc and dilute hydrochloric acid. What is this nascent hydrogen atom? This is the atomic hydrogen obtained when zinc metal react with dilute hydrochloric acid, and the reaction will be Zn plus 2HCl give ZnCl2 plus 2H. This 2H are the nascent hydrogen called as atomic hydrogen. This is a very reactive hydrogen. So here we will study one example. CH3I is a methyl iodide. This is an example of alkyl halide. When nascent hydrogen are added in the presence of zinc and dilute HCl as a catalyst, then we get CH4, that is a methane, and the side product is hydrogen iodide. So methane is alkane obtained from methyl iodide. Second example is CH3CH2Br is ethyl bromide, is an example of alkyl halide. When nascent hydrogen are added in ethyl bromide in the presence of catalyst zinc and dilute hydrochloric acid, then this one hydrogen react with bromine, that gives the side product as a HBr, and the position of bromine is substituted by other nascent hydrogen atom. So this ethyl bromide becomes CH3 single bond CH3 is a ethane. In this reaction, there is a one correction, there is one printing mistake. Instead of here 2 molecules of ethane, there is only one molecule of ethane is formed in the reaction. So if you replace this 2 molecules of ethane by one molecule, then it will be balance the equation. Then second way to obtain the alkane from alkyl halide is by using reactive metal. So reactive metals are sodium metal, magnesium metal. Now we will study how will you obtain alkane by using sodium metal and magnesium metal. This in 19th century, alkyl halide were transformed to alkane, having double the number of carbon atoms by Wood's coupling reaction. This is important reaction in organic chemistry, and this is using reactive metal like sodium. Actual reaction is CH3Br is a methyl bromide. When two molecules of this methyl bromide react with two atoms of sodium metal in the presence of dry ether, then we get CH3 single bond CH3 is ethane plus side product is 2NaBr. Here, the two molecules of methyl bromide are converted into one molecule of ethane. If we observe carefully, then using one carbon containing alkyl halide, we get two carbon containing alkane, and this is advantage of Wood's reaction that we get alkane from alkyl halide, and that alkane having the double the number of carbon atoms, and this is called as a Wood's coupling reaction. Later, this better method using metal like magnesium and lithium were developed, and this we will study now. The Grignard's reaction is one of the new methods widely used for the preparation of alkanes. Again, this is important method by using Grignard's reagent. What is this Grignard's reagent? Grignard's reagent is alkyl magnesium halide. General formula of Grignard's reagent is RMgX. Here R is alkyl group, Mg is a magnesium, and X is halide. So alkyl magnesium halide is Grignard's reagent. First we will study how Grignard's reagent is prepared by using magnesium metal. So we know Rx is a general formula for alkyl halide. When it is treated with magnesium metal in the presence of dry ether, we get alkyl magnesium halide, and this is Grignard's reagent. Now we had prepared Grignard's reagent. Now we will study how alkane is obtained by using Grignard's reagent. We know Grignard's reagent is RMgX. When treated with H2O, that is water molecule, in the presence of dry ether, then the middle part of this reaction, that is MgX from the Grignard's reagent and OH group from H2O, that gives the side product as MgXOH. It's a magnesium complex, and the remaining part is R is an alkyl group react with remaining hydrogen that gives RH, And we know RH is a general formula for alkane. Now we will study the particular example how particular alkane is obtained by using Grignard's reagent. We will take the example of R group as a methyl, that is CH3. Remaining part is magnesium iodide. So this is total methyl magnesium iodide. It is one example of Grignard's reagent. When treated with water molecule in the presence of dry ether, it gives CH3H, and CH3H is a CH4. We know this is methane, and MgIOH is the side product. So this is the example in which we can prepare alkane by using Grignard's reagent. One more example, similar example we can write here just by replacing CH3 group by C2H5 group. So if we use ethyl magnesium iodide, then we get ethane. If we use propyl magnesium iodide, we get propane. So corresponding alkanes will be obtained by using this different Grignard's reagent examples. And that is about the study of preparation methods of alkane. We had studied first as an industrial preparation of alkane, then laboratory preparation methods of alkane using unsaturated hydrocarbon and using alkyl halide. Thank you.